The broadcast is now starting. All attendees are in listen-only mode.
Good morning. It's October 25th, and thanks for joining us today for our settings webinar. My name's Jeremy Henick. I do business development for Icegraph in North America, and I also have Joe Belland on the line today. Joe will be doing the majority of the presentation. Today we're going to be talking about the settings in the software. We'll go over the whole reliability workbench, but it'll probably depend on what questions come up. We have a list of the most commonly asked questions. In the FaultTree software alone, I think, is there 144 options, Joe, or is 184?
I think it was 184.
Yeah, so there's quite a few options. I mean, default settings work pretty good for everybody, but it is good to know how to change certain settings in the software if you want a different result. This is actually a webinar I added to a list we already had. We were going to move on to simulation, but we had several requests for this webinar. So we've added this to our list of webinars. We've already gone through several webinars.
Can you share your screen?
Oh, can you not see it?
Yeah, not yet. There we go. Thank you.
Okay, sorry about that. So we've already gone through several webinars covering FaultTree, the 61508 Famica.
Sorry, Jeremy, it still hasn't loaded on. It's not on my end.
It hasn't shown up yet?
Not on my end. Maybe I'm just lagging out. Are you sharing the right screen? The right monitor?
Yeah.
Okay.
Anything?
Not yet.
I might just have to hand this over to you, Joe.
Okay.
For those of you interested, our past recordings are available on our webinar, so you can catch up on anything you might have missed in the past. But since I'm assuming that no one else can see my screen similar to Joe, so I'm going to pass controls over to Joe and let him get started.
There, it just popped up on mine. Sorry, I think one of us was lagging out, possibly me.
Okay, well, I'm passing controls over to you right now anyway.
Sure, okay. There we go. Let me know when it shows up.
So I can. Yeah.
Okay, yeah. Okay. So as Jeremy mentioned, what we're going to be doing in this webinar is focusing on some of the project options. I actually checked for purposes of when we send out the web meeting announcements. I looked at the number of fields or settings in the table that stores the project options, and there's 184 different fields, and that's for the FaultTree options alone. So there's other options for the other modules of Reliability Workbench. We'll be focusing on the FaultTree module today, but we'll see a few options from some of the other modules as well. And of course, if you have questions on some of the other modules, I'll answer all those as well.
Oh, Joe, one thing we should probably point out really quick. If you have questions, please post them in the questions dialog. There's kind of a pop-out that appeared on your screen when you joined the meeting. You'll see an option for questions. Please post any questions you have in there. I'll probably answer some of my own and then ask some of them to Joe.
All right. Yeah, thank you, Jeremy. Yeah, periodically I'll stop and field any questions that you have. If you have questions about what a specific option does, we'll probably save that for the end. If you want more elaboration on one of the options that I'm showing, I'll pick up those questions mid-webinar. Okay. So in the email that Jeremy sent out announcing this webinar, there was a number of different common questions that come up. So I'll go through and answer each one of those, and I'll also show a few other settings and options. And we'll start with what is literally the most frequently asked question on the Reliability Workbench. This is in my 13 years with Icegraph, this is the one that I have answered the most as a technical support consultant. That question is, so you run your FaultTree and you want to view the results. So you go to Q equals, you look at the results. There we go, there's my answers. You look at your results summary. You want to look at the cut sets. jump to the cut sets, and then you see, oh wait, why are there only 2 cut sets for this huge tree? Wait, what's that star next to the gate maybe? Why is it not showing the inputs to that gate sys1? Why is it just showing sys1 and the star? Well, that's what it's indicating there is that gate has been modularized. Modularization is a technique that FaultTrees use to make the calculations faster and more accurate. The drawback is that full cut sets for the tree are not calculated. This is primarily done to save memory and computation time. Now, for a small tree, this is just the FaultTree cooling example that comes with the project. This is a small one, so any in the last 20 years could easily tackle the full cut sets for this tree, but the program options are default to speed and accuracy. So it's by default not going to calculate the full cut sets for the tree. If you want to view those full cut sets, there is an option that you can turn on to have it show the full cut sets. It's just a little bit buried, so unless you know what you're looking for, sometimes it's a little hard to find it. So I'm going to point that out to you now. And I think some of you probably already know where this is. Either you already contacted me or you might have found it on your own. But anyway, we're going to be going through the project options. This is basically today we're going to be looking in the project options dialog for all these different settings. And the one I want is on the Sets Generation tab. And there's this Approximation Methods frame here. I choose the Custom Radio button, but it's not set by default. I've already chosen the Custom Options. That enables me to open the Custom Options dialog. And in that Custom Options dialog, there's a checkbox right down here on the left-hand side called Expand Modularized Sets. I think you might see why people sometimes have a hard time finding that option. You have to go through a couple dialogues and you have to know which tab exactly to find it. So it's not always immediately obvious. So don't feel bad if you can't find it on your own. But now we know, right? If you check that option, and then you have to click OK to dismiss both dialogues. That's what that tells Reliability Workbench to do. Is it will still modularize for the purposes of calculations, because again, it's faster and more accurate for calculation purposes. But when it's done performing the calculations, it will then expand all the modularized cut sets, and that's for the purposes of display at the end of the analysis. It displays the full cut sets. In order to view them, I need to run the analysis again, so I have to click the green traffic light to have it analyze the tree again. And now when I go back to the results summary, you'll notice it's still modularized, but I have this other checkbox down here, Expand Sets. I check that. It will now show the full minimal cut sets for this FaultTree, for whatever gate I have chosen. That Expand Sets is for all gates for which retain results set. So for any gate that appears at the top half of here, that Expand Sets option will apply. Okay. Also, I should mention while we're here that cut set expansion also applies to the importance analysis. If you're using the importance analysis to view which events are the big contributors to system downtime or system availability, the event importance is also calculated based on the modularization. So if you want to view the basic events that are the big contributors, then you should make sure to expand sets. So for instance, if I go back to my cut sets and uncheck the expand sets, you'll notice on the importance tab I only view those two modularized gates and sys1 and the basic thing here, heat exchanger failure. So it's tied to the cut set expansion is tied not just to the cut sets, but also to the importance analysis. Okay, that's a good one to keep in mind. Jeremy, were there any questions on that while we went through it?
No.
Okay. Yeah, I think it's one of those things like once you know where it is and what it does, what that option is, and why it works that way, it's kind of a you get it after the fact type of deal. Okay, let's talk about another option that we have. Sometimes you'll be here. I'll start a new project for this one. Sometimes you'll be working with a new project, so you'll add a new failure model. You're typing in all your failure data, and you open enter a failure rate. So you create a new failure model using the rate model, and you'll see it's asking for a failure rate and a repair rate. But of course, as a reliability engineer, you know those are both united measures, failures per unit time. So you might start asking, well, what's the time unit supposed to be? Failure rate, is that failures per million hours? Is that failures per year? Is that failures per geological epoch? Or what exactly is that supposed to represent? Well, the default setting for the reliability workbench is that it doesn't really care what your units are so long as they're consistently entered throughout the project. We call that the unspecified consistent units. The units aren't specified, they're just consistently entered. And that's fine for most users. If you're entering information from a data sheet, and you just enter the information as is, so long as it's consistent. And most people can work with that. It can get a little confusing if you're entering data from multiple sources, and the sources don't necessarily agree on the failure rate units. In that case, you might want to remind yourself what exactly that is. Because I've seen this happen before, where a user, it happened once with a user was using the dormant model, and they entered the failure rate in millions of hours, and then they didn't realize that they weren't quite thinking it quite through, and also entered mean time to repair in the same, forgetting that they were in millions of hours. They were thinking MTTR in hours. So they entered MTTR of 5, thinking it was 5 hours, when what they accidentally just entered was a mean time to repair of 5 million hours. That, as you might expect, threw off the results a little bit. So it can sometimes be helpful to have a reminder of what those units are. We can set that by changing the unit options, the project options. So if I go up to my project options in the Reliability Workbench, and this time I'll go to the General tab. Very top of the General tab is this frame for units. And you can see here's that unspecified consistent option. If we uncheck that, then we can directly specify units for the failure rates, and also separately for the mean times to repair. So I can say my mean times to repair are in hours, and my failures, let's say my failure rates are failures per year. So I click OK, and now when I add a new failure model, you'll see next to the text boxes, it puts a little label letting me know what the units are. So both failure and repair rates are in the same units per year. If I do, say, the dormant model, now it shows me my MTTRs are in hours. So if my user does that, 100 failures or 100 years of MTTF, and they say, oh, my MTTR is 5, now it actually is 5 hours. You can see that it's not 5 years. So it makes it a little bit clearer what those units represent. One thing I should mention is that because this also throws off some users sometimes, is the system lifetime. If you're specifying the system lifetime in the project options, that system lifetime will be in the same units as the failure rates. So if the rates of failures per year, that system lifetime on the calculation tab, that system lifetime will also be in years as well. It doesn't put a label, so that's why I'm just sort of specifically pointing it out. You kind of have to just remember that this will be the same units as the failure rates. Because this will also throw off people. Sometimes they'll not realizing they're entering a system lifetime of 1 million hours or something like that. Okay. There's a few other advantages to setting or specifying the units here. Obviously, one of them is that it will now display the labels on the failure model dialog. It makes it a little easier when you're entering it. The other advantage is if you're using a library, if you're using our parts library, or if you're linking to another module, Reliability Workbench can automatically do the failure rate conversions for you. So let's say I'm using the NPRD library, NPRD 2016. Give it a second to load, get it in the big library. NPRD 2016 gives all its failure rates. So this is, let's just take the very first item. This failure rate is 46, and then if you'll scroll off to the right, let's say it gives the failure data format, failures per million hours. Now, if I use unspecified consistent, if I take this failure data from NPRD, it will just copy this failure rate verbatim and use it in the FaultTree. But that might not jive with the other failure rates I've already entered. Maybe I've already been using hours or failures per year in the other failure models I've created. Now this will get sort of messed up when I'm suddenly dropping a failure rate that's actually supposed to be in failures for millions of hours. However, if I specify my failure rate units on the project options, when I copy this into Reliability Workbench, which is dragging and dropping, creating the failure model, you'll see it will automatically convert from 46.72 failures per million hours to 0.409 failures per year. It automatically did the conversion because I have specified the units. So that's one of the other options, one of the other advantages. And that also applies when you are converting from another module. If I jump into the prediction module, prediction and Famiga are both united modules. They don't have that unspecified consistent option. So the prediction options, you always set a failure rate. So the default is failures per 10 to the 9th hours, which is consistent with some prediction standards. I think Telcordia has all its calculations in 10 to the 9th hours. A few of the other standards do as well. So if I specify a failure per 10 to the 9th hour, and then just add a simple block here. So it calculates according to here I'm using the 217 standard, failure rate of 7.013 failures per 10 to the 9th hours. I'm going to copy this into FaultTree, which I can convert my prediction hierarchy to FaultTree. Yep. And now it will have converted, I didn't pay attention to what was it, 7.013 failures per 10 to the 9th hours. It converts it to 6.14 E-5 failures per year. So it automatically does those conversions so long as the units are set. So even this is something I just tend to do whenever I'm working in the FaultTree. I'll always specify my units, even if I'm just using hours and I know I'm going to enter them consistently throughout. I made a habit of setting the units just because there's a few advantages that you get from it that can be really handy in certain cases. Okay. Hope you're all able to keep up with that. I think I was moving a little quickly. Jeremy, any questions on the unit options?
Yeah, is the system life mission duration or design life?
It's what you need it to be based on the analysis that you're performing. So in certain cases, someone might build a fault tree to represent a manufacturing facility. And they're going to want to know how many failures am I going to have over a 20-year plant life. So that's what their system life would be, 20 years. Other cases like aerospace, they're saying what's the probability of a failure during one flight. So the system lifetime would be flight time, 1 hour or 4 hours. So the lifetime is what duration do you want to examine the system over. Do you want to see the failure before the next shutdown and overhaul? Do you want to see the number of failures over the whole life? Do you want to see the number of failures over a particular mission duration? It's whatever you need it to be for the analysis you're doing.
Okay, thanks.
Okay, let's take a look at some other options. So far we've been looking at some small fault trees, but what happens when you get into some really big fault trees? So I have somewhere in my cutoffs. Okay, so this is actually a sanitized version of a project that a client sent to me. And I think the issue they were having was that it was taking forever to analyze, and I can actually show that to you, although be aware, because I think it'll crash Reliability Workbench if I try and analyze it as is. The problem is, so I'm running it, you can see, I hope it's coming across on your end, kind of got cut and stopped here at the cut set analysis. It gives me my memory usage and the percent complete, and it's just going to kind of freeze here. And as I recall, it's never going to progress past this. I tried this last night when I was finding a good file to demonstrate this. It's basically, and I'll show you why in just a minute as soon as it's, I'm going to need to import the analysis. I'm just showing sometimes you have a very large tree that just has an insane number of cut sets, just an impractically large number of cut sets, even modularized. There's no way around it, and the program just can't solve it, not because of limitations of the program, but limitations of mathematics. So for this one, I'll import the occurrence analysis. If it lets me. Well, the other easy way is just to kill it this way. There, I got rid of it. Okay. That was just a really large project. I intentionally picked a very, very large project that would not be able to run in a reasonable amount of time. So maybe you end up with one of those where you open up some projects. One of those huge, huge projects that just doesn't run. And if you want to know why exactly it is, let's take a step down from here to show this fault tree. I have an AND gate, and I have all these inputs to this AND gates. Notice these are all OR gate inputs. So basically, one from each of these needs to fail, right, in order to fail this gate. But then we have to find every single combination. And I think there's 18 inputs here. Right, so it's basically a mathematical problem of 18 choose 2. And if you know that, it's going to be in the millions or billions of cut sets. So that kind of presents a problem for the cut set analysis. It's just impractically large to solve. So how do we deal with that problem? Crash reliability workbench, I had to abort the analysis for the task manager. So how do we solve this fault tree? Well, there's some options that we can set to help you along. One of the best ones to use when dealing with very large fault trees is what are called the cutoffs. You might have gotten tipped off about that because that was the file name. Cutoffs. If I go to the project options, we'll go back to the sets generation tab. You may have seen on the left-hand side these order cutoffs, probability cutoffs. A cutoff is basically you can tell the program to ignore a cut set if it doesn't meet a given criteria. Order cutoff will ignore cut sets that are above a certain order, i.e. they have more than a certain number of events. Probability cutoff is to ignore cut sets that are below a certain probability or frequency. The idea being if they're very, very low, they're insignificant contributors, so just ignore them. And so in this particular example project, the problem was that there were so many cut sets, but all those cut sets, those cuts, each one's going to have 18 different events in it. So it's going to be insanely low probability. So they're probably not significant contributors to the results of the tree. We have all these little cut sets that really are highly, highly unlikely to occur. So these are prime candidates for being ignored if we are setting the cutoffs. So what I'm going to do is I'm going to turn on my order cutoff and I'm going to turn on my probability cutoff. And I might want to play around with these values as I'm running the tree, find some good settings that give me good results, but still doesn't take too long. So I'll set my cutoffs, and then when I run the analysis, it runs through it, and wow, that was so much faster than the crashing that it did before, even hanging up at the 93%. So as it got through it, then it started looking at all those different combinations of 18 possible inputs. It just said, none of these are ever going to happen. They're so unlikely that all 18 of these events will occur. So just discarded them. And so it calculated the top gates unavailability. It did the calculation very, very quickly, and it just ignores all those highly, highly unlikely cut sets. They're so unlikely that they're really not impacting the results. But so we're getting some an accurate result at a much faster speed. You might ask, how do I know how to set those cutoffs? And that's a very good question. There isn't ever really a hard and fast rule or rule of thumb. You might take a guess based on your the failure rates and the basic event unavailabilities. The way I did it for this particular project is I started with very, very high probability and small order cutoffs. We started small. All those values. You started very, throwing out a lot of the cut sets, and so you get it to run in a reasonable amount of time. And then you start relaxing and loosening the cutoffs until you sort of find a balance of where it's not you're increasing the number of the probability, or you're decreasing the probability cutoff, increasing the order, and you look for where the top gate value is not changing as you go to higher and higher orders, but it's still running in a reasonable amount of time. So there is a little bit of trial and error and playing around trying to find the right cutoffs that'll give you a good result in a reasonable amount of time. And again, this is usually only applies if you're working with a very large fault tree like we're going to have here. There's also a few options. You noticed it showed the memory requirements, and for the most part, you're probably not going to exceed the memory limits. But this is one of those places where the 64-bit version of Reliability Workbench can actually come into play. I'm actually using the 32-bit version. That's what I sort of default to of Reliability Workbench. But the main difference between the 32 and 64-bit versions of Reliability Workbench is memory usage. And that usually comes into play with cut set calculations. If you're working with a very large project that has a lot of cut sets and you don't want to discard them because they are significant, then maybe the 64-bit version will help with that. It'll still probably take a long time to run. The 64-bit version at least can handle can use enough memory so that you won't run into memory issues. One more calculation speed setting that affects it. This went into a few versions ago. Is Reliability Workbench is now what we call a multi-threaded application. That's a programmer jargon for meaning that it can run, it can do multiple things at once. You know, where all the new computer processors, we talk about quad-core processor or something like that. Talk about on your phone and your tablet has a quad-core processor. What exactly does that mean? It has to do with how many processing threads it can perform simultaneously, how many instructions can be simultaneously performed. So Reliability Workbench is a multi-threaded application, which means that it can take advantage of those quad-core processors, and it basically is one of the ways that it can calculate or speed up calculations. Okay. Let's talk about another method of speeding up the analysis. One of the things that Reliability Workbench does is it employs approximation methods. Approximation methods allow it to, when there's a lot of cut sets, if you've ever looked at the help file and explained the calculation options, the exact calculation formula is very, very complex. It increases in complexity exponentially with regards to the number of cut sets. So if you have one of those trees with 1,000 cut sets, it's probably not going to be able to, just physically impossible to use or computationally impossible to use the exact calculation. So that's why Reliability Workbench will often resort to approximation methods. And so this is another tree I have to demonstrate that. This is actually a really interesting tree that another client sent me. It has been sanitized, and the descriptions and labels have been removed. But the issue with this one was the user had been using FaultTree 11, and when they switched to Reliability Workbench 11, they started getting different results from the fault trees and started to wonder why. I examined it and I actually found out it's because Reliability Workbench 11 was giving more correct, more accurate calculations because of some of the modularization settings that had been made. With FaultTree 11, it didn't quite have the same modularization capabilities. Anyway, when I ran the analysis, I noticed that I look in the result summary, and you may have noticed this too when you're looking at the result summary for your program. Down here, it talks about used method. It says asterisk Roshan. You might wonder what that's all about. If you looked it up in the help file, and it talks about the different calculation options. It'll talk about the cross product versus the asterisk Roshan versus the rare approximations. I'm not going to go through all the math behind them, but just I'm just pointing out that you might realize that asterisk Roshan is an approximation method. And you might start to, that might make you nervous. If it's approximating the answer, does that mean it's not the exact answer? The answer is no, it's not exact, but it's generally pretty good. But you might want to start to wonder, well, do I have control over that? I mean, it's using the approximation method. Can I tell it not to? Because it's really important that I have the correct answer. Well, Reliability Workbench will try to give you the exact calculation, but sometimes that's just not practical, and that's when it resorts to the approximation methods. This particular fault tree, the reason I'm showing this one is because this is one of those interesting cases where it will switch over to the approximation method, sorry for Sean. However, there is a way that I can force it to use the exact method. Let's just show about this. I'll actually show where these approximation method settings are made. we go back to the sets generation and the custom options where we set the cutoffs, or excuse me, the cut set expansion, expand modular sets. At the top of this dialog is a option for quantitative calculation method. This has to do with the approximation methods. You can directly choose an approximation method, or the optimum upper bound, which is where it will try and use the exact, and if it can't, then it resorts to an approximation method. The way it works is this product terms limit is how the program decides how far, how much it's going to try and use the exact method. It uses it until it exceeds this product terms limit. And again, I'm not going into the math behind it, but if you look at the file, or if you've been to our training and we talk about the exact calculations, that might make a little more sense what that product terms limit means. The default setting is 1,000. We'll try 1,000 product terms. If it can't solve it within that, then it resorts to an approximation. And that's set for speed, but this is one of those options that you can actually increase. So for this particular example, I can increase that and then rerun the analysis. It'll take longer. It took about a couple seconds longer to run the analysis. But you'll notice I got actually slightly better results. That's the thing, is the approximation methods are guaranteed upper bounds. So they're going to be above the exact value. So it's erring pessimistically. It's erring conservatively. So you're not going to get a result from an approximation that's lower than your actual unavailability. Now you can see if I go to the result summary, you can see it's using the cross product method now, which is the exact calculation. So now I can have a little bit more confidence in my results. So I do want to emphasize that this is a very rare case. I had to search through my archives to find a particular fault tree that met these criteria of when an approximation method or the product terms limit actually comes into play. But if you have a reasonably sized fault tree, and you here it's based on the number of compact sets. I have 44 compacted modularized cut sets. That's really the sort of the determining factor. If you have sort of a medium range, I'll define medium range as somewhere between 20 and 100 compact sets, that's about the time when you might be able to force to use a cross product by upping that product terms limit. Yeah, so again, it doesn't happen too commonly, but if you have a larger tree and you want to see if you can try and get it to use the exact calculation, you can try playing with that product terms limit, upping it a little bit to give it a little more breathing room with the cross product method. Okay. Sorry if I lost anybody there, if I went above your heads. This is where it sort of gets into the heavy mathematical calculations of the tool. And again, some of these options, they're sort of tucked and hidden away specifically because you have to have a really strong working knowledge of the analytical methods and calculations and computations in order to understand what these options do. We choose default options that we think are best for most users. Again, we err on the side of speed and accuracy over giving more cut sets and things like that. So we try and set default options that work for most users, but you know, sometimes you have to play around with some of these mathematical options to get what you're after. Anyway, Jeremy, have there been any questions on any of that I've been going through?
Yeah, there's a few questions. I think you've addressed some of them with the presentation. Over in the 61508, the failure model, there's an option for overhaul interval as a parameter. Mm-hmm. How does that parameter and system lifetime interact?
Right, so they're unrelated. When you're using a dormant or 61508 failure model, the system lifetime is not used in the system calculate or in the unavailability calculation for that basic event. It only uses, so the dormant model only uses the test interval in its calculations. The 61508 model uses test interval and overhaul interval. So system lifetime is not directly used in calculating unavailability for either of those two failure models. The system lifetime will only be used when calculating unreliability and number of expected failures and related parameters. I hope that answers the question.
Thanks.
Okay. Let's take a step back from some of those mathematical options. And I presented those because these are some of the important stuff, because it is a mathematical tool. It is doing these hard math calculations, and we want to make sure they're accurate. So I started off with all of those because I think it's important for the user to understand what these calculations do, how the program arrives at them. That's why whenever I give the training, I always focus on the math, even though a lot of users are just there doing the software. Because as a mathematical tool, it is important that you understand that. But let's take a step back from all that and get more into the just the usability of the tool, some of the options that you might improve your life when just working with the tool, not necessarily in a calculation perspective. One of the things that comes up some of the time is you're working in the tool. We're all used to, we're sort of getting used to working in the cloud or working with Microsoft Office, which Microsoft Office, remember back in the day, like when I was in high school or in college and you're working in Word and then your computer crashes and you lost the last 5 hours of your work in Microsoft Word. Remember that? Well, it's kind of gotten a lot better. Word has really improved so that it's auto backup, so your computer crashes now. Next time you start, Word has this little recovery panel. It says, this is the last version of the document that it was able to auto recover, and it was like a couple minutes before your computer crashes. You think, oh, thank God, we're okay here. Well, I think that spoiled us a little bit, so we sort of expect that. And then we run into problems with when we're using Reliability Workbench because, oh gosh, it doesn't do that auto recovery, so it crashes and we do lose those last 5 hours. Well, don't fret too much because there is an auto recovery option, kind of like Word, not quite the same, but there is an option to have Reliability Workbench do your auto backups. The default the difference is that setting is defaulted to off. So that's why I pointed out. So this is something that you might want to think about very sincerely. In the application options, which I haven't been and often we don't pay as much attention to. The application options is this little monitor icon on the toolbar. You can also get to it from the Tools menu, Tools, Options, then Application. Second tab is Backup, and there's a setting to enable project backup. There's a special backup folder that you can find, and the default interval is 60 minutes, but heck that, I'm going to have it much lower value. 10 minutes auto backup is what I'll set. This way, every 10 minutes, Reliability Workbench will save a backup of the project to this folder here. That way, if something goes wrong, if the program crashes, or here's another case where you use it, you accidentally mess up, you delete something you didn't, and it's unrecoverable, you can resort to your last backup. So that's a big quality of life improvement, is to set that project backup so that it gives you a little bit of peace of mind knowing that you can't ever mess it up too badly. One of those other quality of life improvements is the Undo tab. You've noticed the undo options, I'm sure. When you make a mistake, you go hit undo. But if you've made a lot of mistakes or you want to go back a lot of steps, you might have noticed that you don't limit after a certain number of times. There's a user-defined limit for the number of undos that you can set. The reason for this limit is that the way that the Reliability Workbench does undos is it saves a complete backup of the project in memory. Whenever you make a change, it just swaps up those backups that are stored in memory. Now, for a small project like that FaultTree cooling example, the project only takes up like 100 megabytes of memory. If you're running 8 gigabytes of memory, you could have a few hundred backups in memory. Your computer can handle that. If you're working with a large project that's like a gigabyte of memory usage, then you probably don't want to save too many versions of memory. So it's kind of a memory trade-off. So that's why the default setting is set at 4. Again, we usually err on the side of speed, and the more backups it saves in memory, the more of your computer memory will take enough to sort of back off on that, not suck up all your system resources. leave that option open to you, you can change how many undos are allowed. This is a setting I don't normally change that much. I usually don't go too far past that. And if I think I'm going to need to step back several steps, I usually just save the backup of the project. But you can up this, say, make 10 undos. That way you can undo the last 10 things we did. So that's, again, another one of those quality of life improvements that allows you to change that. Also, again, if you're working with a very, very large project and you're trying to reduce the memory usage that the program is taking up, then you, again, might look at the undos. Try lowering the number of undos, set it to 1 or 2, and you'll reduce the memory used by reliability workbench. Okay. Let's talk about some more quality of life improvements. Let me open up my FaultTree. This project here. A few other options that we might set. Okay, when I run the analysis, what's the default scale? Yeah, the default diagram scaling. Oh, hey, by the way, did you know with reliability, just sort of an aside, with reliability workbench 13.0.1, which we just released, I think, a month or 2 ago, we finally, this was a lot of people were asking for this, we finally introduced mouse scroll wheel support. You hold down the control key on your keyboard, which I'm doing right now. You can't see it. And then you scroll the mouse. Pretty nice, huh? Okay. That's kind of an aside. You can also scroll up and down as well. I know it's not going to be very fast over the connection. It's going to be lagging out a little bit. Anyway, that's kind of an aside. But the one thing I wanted to talk about is displaying the different values underneath dates and events. Right now I'm showing Q unavailability. In one of the other trees I was just showing, it showed QT unavailability per flight hour. What if that's not what you want? What if you want MTTF? Or what if you want unreliability? What if you want conditional failure intensity, the failure rate? And you want to display that. I think this is an option I think most users know about, but just in case you've never encountered it, you go to the view options. You have quite a bit of control over what displays on the tree. So things like showing the event failure parameters underneath the basic event, showing the failure model ID, like FM1 there. Those are options that I have set. And also options for displayed gate results. Mouse unavailability. We put that over to say frequency or CFI, or I don't think MTTF is calculated in this tree. Maybe we'll turn it on. And oh, here's that view tab. You can also set the displayed event results. So if you want to show the event unavailability, let me turn those options on. I need to rerun the analysis because I should run the MTTF analysis. But now instead of saying Q under the tree, it shows MTTF instead. And again, I think most of our users know about that. But again, sometimes it slips under the radar. Sometimes people don't know about it, and they want to know how can I display a different result. So you don't have to go to the result summary every single time you make a change. You want to see how it affects the parameter that's relevant to you. Because unavailability isn't relevant to everybody. Some people are more interested in frequency or MTTF, something like that. So again, that's under the View Options menu. There's a few other options that will come back. I'll point out a few other options as well. One more thing I do want to point out is the precision. Right now it's showing, looks like 4 digits of precision. You might want to change that. How do I just change the precision? Or more commonly, it's how do I force scientific notation? You'll notice there's just kind of a mix here. It's showing 0.5. Here it's giving this one in terms of scientific notations, mixing the two together. And sometimes, particularly when people are most interested in the order of magnitude, they're interested in the exponent. They want everything in scientific notation. So they might ask, how do I do that? And again, you can do that in the project options. This time I have to scroll way off to the right. Notice that along the project options, the tabs along the top, the different tabs in the dialog. On the right-hand side, there's 2 arrows. Because there's actually more tabs than fit in the dialog. So you use the arrows to scroll to the right to see the rest of the tabs. So I scrolled all the way over to the right, and the very, very, very last one is the precision tab. I can change my both the display precision. Default is 4 digits. You can increase that or lower it. and also change whether or not the floating point format is automatic, which chooses it when it can't fit it. Basically, here where it's the exponent is times 10 to the negative fifth, we'd have to have too many leading zeros, and it wouldn't really fit well. So it decides, well, you know what, we're just going to do scientific notation. But you can force that. I'd say exponential to pretty significant digits. It does that for everything. That rounds appropriately. Let me go back to the view options. Show the gate unavailability. So you can see the, makes it a little bit easier just to see the order of magnitude if that's the most important thing. E negative 3, E negative 3, E negative 2. Because that's what a lot of people are sometimes interested in. Okay. Precision. Let's see, what other options are of interest? Oh, this is an
Joe,
important
maybe
one. Oh, sure. Go ahead.
maybe it's worth talking about for a minute, because there's a couple questions, which we always get a lot of questions on this, is why we've chosen to do units the way we have, so that they're not, you can't choose different time units, for example.
Oh, for each basic event, why you can't choose one basic event in hours and then another in years?
Yeah, so there's a bit of history on this, because there is a reason why we do it this way.
Yeah, do you remember exactly what it was? It was, I know it goes back a ways. I think it had to do with confusion. A lot of people were messing up their fault trees. Wasn't that related to that?
Yeah, so many versions ago, we did introduce an option where you would enter units, and then you would choose what type of units they were, whether it was hours or days or years or whatever it might be. And then after people upgraded to that version, we were getting endless support calls because people were having problems with their trees and their calculations, because the units were being entered differently in different parts of the trees, and they weren't always set since it wasn't a consistent unit. And then we went back to consistent units, and those support questions kind of went away, so we've never gone back to that. So that's probably something we'll probably have a hard time getting our mathematicians to ever consider that again. So we use kind of consistent, inconsistent units in a way.
Yeah.
Where it all has to be hours or days or some kind of consistent time unit.
Yeah, it's got to be consistent throughout the tree, and again, it is related to, I mean, it seems like a nice feature. Oh, you know, I have one data sheet, my my parts are listed in failures per hour, and this other data sheet they're listed in failures per year. Why can't I do that for both of them? And it just comes down to it just threw a lot of people off, and didn't realize which units were entered in which events, and they ended up, again, they start to blame the program. So why is the results are way off? So the results don't match what they should be, and it ends up being it just makes it so much easier to make user error when you do it that way. Okay. Yeah, but that is a good thing to discuss. One more option that I'll mention. If you've ever had to prune a tree, like suppose I know with this cooling leg 2 here, I'm going to move it around. We're considering the design where we only have one cooling leg. So I want to remove this. So I delete it, and then you'll see, you remember all these warning messages when you delete a gate. It tells you all this stuff is going to be deleted from your project. Oh no, I'm going to lose all these basic events and gates. What if I don't want to do that? What if I want to reuse those things? So I delete them, they'll be removed from the project. If I ever want to use, you know, electric valve 2 stuck closed again, I'm going to have to re-enter that basic event. So what if I don't want to delete it? That's something that comes up. What if I don't want to, I want to remove it, but I don't want to remove it from the project. I want to be able to reuse it. This is something that comes up a fair amount of time. To do that, there's an option to do that. You can, if I right-click on a gate or on an event, I can select Remove Inputs and remove it from the diagram without removing it from the project. And with that, you'll notice it disappears, but it's still in the project. Actually, it'll show up as its own, there it is, its own top gate, the FaultTree hierarchy on the left. So that's sometimes when people want to remove stuff without removing it from the project, they just want to remove it from the diagram, but so they have the option to use it. Keep that remove input option in mind. Another way of doing that is there's a project option. Actually, I'll do it. There's a project option. Delete selection and below in FaultTrees. It's checked by default. With that checked, when you delete a gate, it not only deletes the gate, but all of the info beneath it in FaultTree. If you uncheck that, when I delete the gates, only that gate will be removed. All of the other inputs to that gate remain in the project. So you can see those pumps, the valves, the basic events, all remains in the project. That way I can reuse them. So it basically, unchecking that option turns the delete button from deleting a whole branch to just deleting the gate. And again, it's a user preference sort of setting, which is more convenient or which is more in line with what you want, what you mean it to do when you delete an item. Keep in mind though that when you turn off that option, so I delete that gate, I end up with a lot of orphans data. So I have those two gates that are now just floating on their own. I'll have basic events that are not attached to connect to anything. So sometimes you want to clear out that data after you've gone through all those deletions. And there's an option in the special functions menu. It's delete hidden data, basically data that's not logically connected to the current page. So I do all non-visible disconnected. It'll delete any data that is not logically connected to this date or to this page that I'm currently viewing. Back up a step, undo it to add it back in. So that's just something. Those are a few options that you can keep in mind for how delete behaves or how you can remove a whole branch versus just a part of a branch or just one gate. Okay. One other thing that people like to do is a few versions ago, quite a while ago, maybe about 10 years ago, we introduced colors, the ability to change the colors specifically. So you can go to each basic event or item. Notice the appearance tab. You can choose a color for each item and also change the fonts as well. And that makes it very colorful. You can print them out. You can color code items and things like that. Sometimes you want to set default colors. Like, what if I don't like this blue? What if I really like chartreuse and I want to make that my default color for all my gates? Or what if you want to color code things, events differently based on the type of event? For instance, dormant events should be a different color, or house events should be a third color. You have options in the project options for setting the default colors for symbols. So FaultTree, all the gates, etc. I select one of them, I can say change selected color. And say all my OR gates will default to one color, or all of my basic events will be another color. One of the most useful ones, and this is true and false house. I can set default colors for true and false house events. Actually, I have to know if that was true should be red. False should be green, right? There. That way, if I'm toggling an event back and forth between true and false, there we go. Sorry, I'm clicking through all those options really fast and I'm really able to keep up with it. I know the lag between when I do something and when you see it is can also be prohibitive. But as I change it back and forth from, say, a true house to a false house, I can have it automatically recolor the events. There's an option for that. Have it set default colors for everything. That can be handy. You can also set default fonts. What if my favorite font is Wingdings or Comic Sans or something really fun? You can set default fonts for the fault and event trees, the IDs and the descriptions. The text underneath, I can never remember if it uses the ID font or the description font. I think it's using the ID font. But you can do something like, I often do this. If you're making printouts of your FaultTree, I do this for all my training material. I will set it to a bold and a slightly larger font size. And I'll do that for both the IDs and the descriptions. And this way, if you're copying and pasting the slides into another material, it makes the text much easier to read. You can shrink down the FaultTree a little bit to fit it better on a PowerPoint slide, but still have the text legible by making it all a little bit bigger. So again, those options are both in the project options. It gets a little confusing because there's also some font and color settings and the application options as well. There's options for setting the default fonts. This primarily has to do with the tree control. So the tree on the left-hand side here, I can change what font is displaying here. Also colors for the plots as well can be set in the application options. Okay, we're coming up on the end of our time. There's a few more options that I wanted to make sure I get through. So let's, yeah, I want to make sure I get through the reporting options because I think this is the probably the best kept secret in Reliability Workbench is the reporting options. Did you know that there's a separate dialog for the tools, options, reports? Most people don't even know about. This suggests how the fault tree diagram appears in your reports. It also appears what happens when you copy and paste the diagram onto the clipboard. And it also changes how big the fault tree can appear. You'll notice, let me just do a new blank project for this. I do something, just a really small fault tree, and then I open a diagram report, fault tree diagram report. Notice that most of the page is blank, right? So I've got all this white space surrounding my report. Reliability Workbench expands the diagram until it fits a certain size, scales it to up to a certain size, and then it'll just stop at that size. What do you want to be bigger? What do you want your fault tree to take the whole page? You can change that in the reports options, tools, options, reports. There's an option here for maximum fault tree symbol size. That's the width in inches of the fault tree symbols. If I make that, say, 2 or 3, it allows it to scale the symbols up even larger. So say 2 inches maximum width, and then I'll require the report, and it made everything bigger on the page. It will, of course, automatically scale everything down to fit on the page. But sometimes, what if you have a very large paper size? What if I have a plotter and I want to print the whole fault tree on a single piece of paper? I can do that via the page setup. I can adjust the paper size for the reports. It's based on what your printer supports. And my printer does not support, I don't have a plotter. But if you have like a plotter and you can choose oversized paper, and you want to fit the whole fault tree on a single page, let's pretend that letters, say, plotter size. Zoom out of that a little bit. I do need to rescale it as I rescale the diagram. But suppose I want to view the whole fault tree. For this one, I'll choose a bigger file. I'll go back to my cooling project. I want to display that whole fault tree, not just without the pagination. I want to display the whole thing on one single printout that I can send to a plotter. In the view options, there's an option to disable paging, and we'll turn off all the transfer gates. Look at that. It displays the whole fault tree on a single page. And then when I go to my report, the query, it fits that whole thing on a single page. That way, if I'm printing it on oversized paper, I can print out the whole fault tree on a single page. This way, you don't have to manually remove every single individual transfer gate. You can just temporarily disable the pagination for printing out, and then once I've done my printout, I can go back to the view options and or uncheck that, and it'll go back to my default pagination. Okay, let me talk more about those some of those report options. I promise I'll be finished in a couple minutes. There's other options, like you can uncheck the color if you're printing to a black and white, like a laser printer, and it just doesn't look really good. It's just going to do a grayscale when you try and print out that blue. That doesn't look too good. You can just uncheck color diagrams. And when you view your report, that looks much better when you're doing in terms of diagram when you're doing a printout. It also saves toner. And let's see. Oh, here's one more thing. How many people have had a very, very large project, a whole bunch of different fault trees in it, and you decide you want to print out just one of your fault trees. We'll have done that. So in order to do that, you'll do something like the delete hidden data, to delete all the extra data, or maybe you'll copy that one fault tree into a new file, so you can just print out just that one. How many people have done something like that? Now, how many people will be mad at me if I tell you actually you didn't technically need to do that if you just want to print out one fault tree? In that reporting options, best kept secret, there is a page filter option, RBD and fault tree page filter. Well, one of the options is visible and below. When you select that, the reports, fault tree diagram reports, will only be the visible page and all its pages below, connected via transfer gates below. I'll cut out everything else. So if I select just this page, I'll go to my report and requery. My report will be just this one and the related pages. So if you don't want to print out all 580 some pages of your fault tree, you just want 3 of them, you can use that page filter to get just those fault tree pages. Likewise, from that report options, in addition to filtering, you can also change the fault tree page order as well. The default is just orders it by the hierarchy on the left-hand side here, although you can set a user-defined order. I can grab and move pages around to order them as I want. Okay. Yeah, there's a few other options. I'd recommend coming into the report options if you've never seen it before. Some of these are kind of interesting. Let's start page number. Determines how it does the underneath transfer gates. You see it says page 2 underneath this transfer gate and page 3. What if you don't want it to be page 2 and page 3? What if this is on page 400 of Appendix C of your certification document, and so you want that to be reflected in the transfer gates? Use that. Start page number. Adjusts what page number appears underneath the transfer gates. So there's all sorts of fun options like that in the report options. So I'd recommend if you've never seen this dialog before, you can check it out and go to the help to view all these different options. Well, they tend to be somewhat self-explanatory. Anyway, I think we've run out of time. I got through just about all the options I wanted, but if we do want to break for a couple questions before we call it quits, okay. I think we can answer.
We're about out of time, but there's a couple interesting questions there. When you're talking about beta factors, the beta factors that are in a project but not in a fault tree diagram, will they be used in the beta factor averaging? I guess that's kind of
yeah. It took me a while to decipher that question. Yeah, but I think I know what you're talking about. So I think the question has to do with if you have a beta factor that's attached to a basic event, but that basic event is not used in the fault tree. So if I create a new, I just add a new basic event and add a common cause beta factor to this one, and this basic event is just floating right here, but it's not attached to anything. Is this events failure or events unavailability used when averaging the common cause amongst different events that are in the fault tree? The answer is yes, it is. So this basic event, even though it's not in the fault tree, it still looks at that event for the beta factor averaging. Be aware of that. I did actually once help a user who kind of got himself into trouble that way. He had an event that was not used that had an unavailability of 0, and that 0 was being used in the averaging. So be aware and be cautious with that.
Okay. But other than that, Joe, I think we're over time, so we should probably close this up. A recording of this webinar will be sent to you in the email, and they'll also be posted on our blog either later today or tomorrow. So I know we went through a lot of this very quick, and we could probably spend days going through options. But if you have any questions on any of this or would like to kind of watch it in slow motion, feel free to watch the video or get on our blog where it'll be posted. And if anyone has any questions, everyone has my email address. Feel free to email me or give me a call, and any recommendations you have for future webinars. We will be starting our new series soon where we're going to move from analytical methods like the reliability workbench to simulation, where we'll show how you can optimize things like spares and labor, things like that. But other than that, thanks for attending today's webinar. Thanks, Joe.
You're welcome. Thank you for coming.